Okay, so we're going to use this lesson as a kind of a supplement to what we talked about in class, as a little bit of review. So if you missed class, you have this. If you we're here and just need some more information, so review about it. Here's a video kind of helps us talk about what we talked about in section 4-7. Going back to this screen, we're talking about transforming quadratic functions. Now we've done this before. We talked about this in the previous chapter about transforming functions in the first place, talking about shifting them and stretching or compressing them. So here's our kind of a picture of a parent function. We'll get back to that in a second. I just want to go over here to this to show you some different things on how this works. So if you look, I have the general form of any quadratic here where we have a vertex at h and k. So that's that point right here. Then a is a vertical compression or stretch factor. And so if we notice, right now we're centered at 0, 0, and we have just our parent function. So we have some nice points on here. I have the point 1, 1, -1, negative 1, 1, then we kind of shift over and move up. So if I put that graph on there, this is the parent function. It hasn't been shifted at all. Nothing goes. Actually, it's the same function if I just did y equals x squared. And if I take that off, you'll notice it all kind of sits in the same spot. So that's our parent function. That's what everything else is based off of. What we're going to be looking at today is something called vertex form. And that's exactly what this is. If we go back to the other slide in a second, we'll kind of see it more. But this is vertex form. It's very general. It's written so you can see the vertex from the actual equation, which will give us this particular graph. Now, if you notice, we have 3 extra variables, a, h, and k. And each of those do something different. A starts as 1. It can't be 0. If you look, if a is 0, what happens? That graph ends up just disappearing. Okay, it doesn't exist anymore. So a's got to be something other than 0. It can be positive, it can be negative, it can be a fraction. But it's got to be something other than 0. That's the only restriction. If you look what happens now, if we change each of these sliders individually. Okay, let's start with h. H is inside the function. As we've seen in previous chapters, that's with a horizontal movement. So if I start taking h and I increase or decrease, if you notice, the only thing that changes is its location on the graph. It's moving left or right. So h changes the x value of your vertex and all the other x values as well. Okay, so it's a shift left or right. Now, one thing we have to remind ourselves of is that if we change stuff inside the function, you have to think opposite. So if this says x minus, if I made h 5, let's say, if I notice, it went to the right 5. So we had this part here, x minus, it would say x minus 5, that went right 5. Same idea if I went to -3, okay? Notice I'm at -3 now. This would actually be x plus 3. So inside the function, you have to kind of think opposite of what it is, and that will give us that x value of the function. The other part, k, does the same thing. Okay, so move this guy back to 0. K just goes, moves it up, and moves it down. That's all it's changing. Okay, it's moving up and down. Nothing else changes. And what that is, that's our vertex. So if I move k to, say, 4, and h to -5, let's say, you'll notice in vertex form, get that right. I'll get it right here one day. Okay, so at -5. The new vertex over here is that ordered pair -5, 4. That will come directly from this. Okay? Back here, my original vertex was 0, 0. I have now shifted it to -5, 4. Okay, so that's what h and k do for us. They change the values. They change the way things are moved around left and right, up and down. And then we'll look at a. Now, a does something, a changes the graph as well, but in a little different way. Okay, remember, we're multiplying by a, and this is the difference. Multiplying by something changes how it looks in reference to addition or subtraction. So if I just hit this play, you'll see how a changes. And watch how the graph does. A is going to start getting bigger first, then get smaller. So it gets bigger. And notice as it gets bigger, that graph gets closer to the y-axis. As it comes back out, it starts getting wider. So A is getting smaller and smaller and smaller. And then all of a sudden it flipped. Okay? And it's getting narrower and narrower and narrower again. Okay? But it's reflected down. So if we notice when that happens, if we watch, play again, And we get to 0 and it flips up. So if we kind of move this, the closer I get to 0, I'm back where I am. Okay, A is 0, it's a flat line, and then all of a sudden, it reflects down. So going from positive to negative, A not only does a job of stretching or compressing vertically, but it also determines which way the graph will open. Okay, and that will take us over to this particular slide now. As we look at our three pieces of information here, we start with one thing. We can get vertex from this. Okay, your vertex is the ordered pair HK. And don't forget, H, you have to kind of think of the opposite of what that number is here. So if it says -5, it'll actually be 5. If it said +7, it would be -7. All right? And then A does a couple things. If A is greater than 0, it's positive, it will open up. And if A is less than 0, it will open down. That's our first piece. Also, if A is greater than 1, you have a vertical stretch. And if A is between 0 and 1, you will have a vertical compression. Now to review what we talked about before with this, we base all that off our parent function. This guy's our parent function, and everything when we graph other ones is based off of this parent function. And we use that how we get to, you kind of use these 3 points here. Okay, your original vertex is 0, 0, but we want to move to our new points, and we're going to change those based on what the value of A is. Excuse me. So if we start with this, if you notice here, my first graph from my vertex to my first point. In my first movement, I go to the right, and then I go up. And I do that twice. Okay, so first movement is that, second movement still goes to the right and up. And if I notice what happens, I go from 0, 0 to 1, 1. So I went to the right 1, and then up 1. That was my first movement. My second movement came kind of the same idea, but instead of going right 1, I go right 2. And instead of going the same up 2, that would put me here, but that's not where my point is. I go right 2 and then up 1, 2, 3, 4. So using those 2 movements will help us graph any quadratic function that we have. So if we start here, I've got a couple examples we can work on. Okay. Start with your vertex. Well, here, it is in vertex form. So my vertex is going to be the ordered pair. Well, here it says -3, so instead of -3, I actually have a positive 3 for my x value, and then my y value is this guy is 1. So that's the first part. So let me go plot that. 1, 2, 3, go up 1. There's my vertex right there. Okay. Now from there, I can determine a couple other pieces of information. Okay. My first is, what type of stretch do I have? Well, this is a stretch of, vertical stretch of 2. That means instead of going over 1 and up 1, I'm going to go over 1, because it's a horizontal, so that's not change. Oops. I'm going to go over 1 and up 2. It's multiplied 1 by 2 to get that. Same idea for my second movement. I'm still going to go to the right 2 because I haven't changed horizontally, but instead of going up 4, I'm actually going to go up 8 this time, because 2 times 4 is 8. So that's going to be my movement to get to my point. So if I do that, I go to the right 1, up 2. Great. And then I'm going to go to the right 2, up 8. 1, 2, 3, 4, 5, 6, 7, 8. There. That only gives us half our vertex. We just go the other side. So instead of going right 1, we go left 1 and up 2. Remember, because these are symmetrical. There's that axis of symmetry that runs right through here. And then this guy will be reflected over here as well. So there's your graph. You know, you make a nice curve then with it. I'll do my best here to draw this guy in here. And that's going to be what the shape looks like. So that's your first graph. Very similar over here. My vertex, first of all. Let's deal with my vertex. I see +4, so that needs to be a -4 here. I see a -5, so it will be also a -5. So as I graph that ordered pair, I go left 4, 1, 2, 3, 4, and down 5. 1, 2, 3, 4, 5. There's my vertex. Okay. There we go. All right, now as I look at my value of A is 1/4. So that means I have to multiply my y values by 1/4 instead of a number bigger than 2. So I still go to the right one. That doesn't change. I'm not changing anything horizontally. But instead of going up 1, I go up 1/4. Okay? And I still go to the right 2, but instead of going up 4, I go 1/4 times 4, which would be 1. So as I graph that, go right 1, up 1/4. That's going to be a real shallow graph right about there. Then I go right 2, up 1. And same here. Go left 1, up 1/4, and go right 1, up 1. And it's a real shallow graph. See if I can graph that well coming through here. How good my graphing skills are. I'm going to shift that guy over so it sits right top of my letters. Okay, so if we notice, this guy was less than 1, it got squished. It was like a vertical compression there. This guy was bigger than 1, it stretches it vertically. So that's just a quick refresher on how we graph from vertex form. Just remember what you're doing. You're multiplying the vertical piece only here, and you're not changing the horizontal piece at all. Get your vertex, plot it, and go. The other piece of information from this guy is using this vertex form and trying to find a unique equation that fits a certain situation. We've seen this with linear stuff where you're given a point and a slope, and you have to determine what your other parts of your equation are given what you're given. But in here, we do the same idea. You're given a vertex, so that's h and that's k. And you're given an ordered pair. Well, an ordered pair is just made up of an x and a y value. So if we look at vertex form in general, the only thing we're missing is a. That's the guy we have to find first. Once we find a, we can rewrite our equation in the correct form. So we're just going to start by plugging stuff in the right values. H and k, x and y. Well, here's y, so that's 25 equals. I don't know what a is, so I'm going to leave a as a variable. Okay. X, we know, is 1. H here is -2. Don't forget the squared. Parentheses are your friend here. And then plus k is 7. So I've just gone and plugged some values in, and now I go from having 5 different variables to 1, and I can solve for that. So let's do some quick math. 1 minus -2, that's actually 3. So we'll have 25 equals, and then 3 squared is 9. Then you have the a with it, and then plus 7. So we can solve this fairly easily now. Subtract 7. We get 18 equals 9a. Divide by 9. You know a is now 2. So if we want to know this whole function, we can write it a couple different ways. Go back to your original with x and y, stay in x and y. You know a is 2. X minus -2 will become x plus 2 squared, and then plus 7. That's one way to write it. That is vertex form for that particular equation, but we can actually go one step further and write this in standard form. Right, well, I have to follow my order of operations first. I need to square this x plus 2 first. So if I do that and multiply it out, you can either use the pattern or throw it on the 2x2 box and multiply, but you get x squared plus 4x plus 4, and then you have plus 7. Distribute that 2 in, so we have 2x squared plus 8x plus 8 plus 7. And so your final guy in standard form, combine your like terms right there, you get 2x squared plus 8x plus 15. And that is the standard form quadratic for what we just described. It has this guy as a vertex, and it goes through that ordered pair. And that's what we have going from there. So that's your general overview of Section 7. We'll talk about it in the class, but this is a review as you're doing your work. If you're stuck, you can come back to these 3 examples and kind of find out what you're looking for from there. Okay, see you in class.